Hi everyone, I'm Goldie and I'm here to make coding concepts easy to understand. In this video, we are going to be going over the AP CSP pseudocode, specifically how it relates to loops. So we're going to go over the while loop as well as the repeat loop, all within the CSP pseudocode framework. Now, loops in a program help us to repeat tasks, and each of these loops are going to help us repeat tasks in different ways. So I'm going to go over the differences between the two, and we're going to do some practice problems to really help us understand these concepts. So if you're ready, go ahead and take out your notes and let's jump into the material together. So let's first talk about what a loop is. Loop statements, when they're used in our code, allow us to repeat a piece of code many times. And essentially, it allows us to save time as programmers if we can take a task and write it in a loop, knowing that it's going to repeat a certain number of times. It does make the overall code we have to write shorter for it. We call the process of using a loop iteration, and that means just repeating steps or repeating instructions over and over again. And each programming language has different types of loops, different loop syntaxes, but in general, most programming languages have two basic types of loops. And that's what the CSP exam is going to cover, is these two basic types of loops: the repeat n times and the repeat until loop. So let's go over the repeat n times loop. So the repeat n times loop repeats a segment of code for a set number of iterations, what we would call n. And in the loop header, n would be replaced with a positive number. In most other programming languages, this is called a for loop, but it can take on a few different loop headers for it. Okay, so the text code, it repeat n times, you see it there, and then the block code looks like the same thing. And then inside those square brackets or inside the block code, we have a block of statements. It might be one line, it might be a couple lines, it might even have some conditionals thrown in there as well, but we repeat it a certain number of times. So here's a basic example of it. What is the value of A after the code segment has executed? So we'll do a trace of this. So off to the side, we'll write A starts with the value of 5. And then when we get in here, we see we repeat this statement in here 3 times. And what's happening is we take the current value of A and we're going to add 1 to it. So the first time through, I take 5 and I add 1 to get 6, and that becomes my new value of A. And that was one loop. That was the first loop through. The second time through, I take the current value of A, which would have been 6, add 1 to get 7. That was the second time through. And then the third time through, I take 7, add 1 to get 8, and then 8 becomes my value of A. And that's me repeating that line of code 3 times. And I am done. A has the value of 8 after the code segment has executed there. Okay. So even though this line is just mentioned once, because it's in this block of code, we repeat it 3 times. Okay. Let's look at 3 practice problems, or I guess 4 practice problems, just going through the repeat n times. If at any point you want to try this on your own and see if you can determine the output, please pause the video, try it, and then press play when you're ready to see the answer. I'm going to go through each of these practice problems and explain how we get the final answer. So for this one, the variable b starts off as 6, and it says I'm going to repeat this line where I add 2 to b 6 times. So the first time it becomes 8, second time 10, third time 12, fourth 14, fifth 16, and then finally the 6th loop I add 2 and I get 18 as my final answer. Okay. So using a trace like this that you see on a scratch sheet of paper or off to the side can really help you keep track of your variable as it changes throughout the loop. You can also, what you'll see me start doing too, is making tallies. So I use tallies to keep track of how many times a loop has run. So if I need to repeat 6 times and I want to make sure that I'm keeping track 6 times, you can also make a tally to help you go through that. Here, I repeat 2 times this statement inside. C starts with the value of 10. And then I repeat 2 times. So I subtract 3 the first time and I subtract 3 the second time to get a value of 4 for my final value of C. Let's look at a bit of a longer one here. Now I have 2 variables to keep track of. I have the variable called Santa and a variable called Grinch here. And then I need to repeat this set of statements 4 times. So Santa and Grinch, they each get started with a variable value of 10 and 50. And then I repeat 4 times. So you can see my tally marks kind of starting here, just to keep track of, hey, I'm repeating these 2 lines of code in order 4 times. So the first line of code, Santa, the current value 10, gets 5 added to it and becomes 15, and that becomes the new value of Santa. The second line takes the current value of Grinch, which was 50, and subtracts the value currently stored in Santa, which is 15, because it was changed in the line right before this. So 50 minus 15 is going to give us 35, and it says we store that in the variable Grinch. That was 1 time through our loop, and we want to repeat 4 times. So the next time through, I'm going to go through the same thing. Santa, which is currently 15, gets 5 added to it to become 20. And then Grinch, which is currently 35, gets 20 subtracted from that, and that becomes 15. So that was 2 times through. The third time through, Santa gets 5 added to it, and then Grinch, which is currently 15, gets 25 subtracted from it. So then it becomes a negative 10. And I can see that's 3 times through. So once I reach this last line in my loop, okay, once I reach this end block, I go back up and I make sure, do I have to repeat again? And in this case, I do. I need to repeat 4 times. So I'm going to do this one more time. So I take 25 plus 5, which is 30. I take negative 10 minus 30 here to get my new value of negative 40 for the Grinch. And those are my ending values for the variables. So the more variables you have, the more you'll probably want to use this tracing table off to the side, do some scratch work, and make sure you're keeping track of how many times that loop runs. The last practice problem for the repeat n times, I want to take you through a repeat, but also use a conditional in there. So just looking at this before we start tracing, you'll have 3 variables. You'll see here you have this big loop repeat 5 times. And in here, you'll see both the variable assignments as well as a conditional statement. I see I have an if and an else statement in here. Okay. So you can have however many lines of code inside your loop here. And we're going to repeat this 5 times. So we're going to get our trace ready. So I'm going to start off with those 3 variables, x, y, and result, and make sure I have them labeled in my table, 3, 4, and 0. And then I'm going to go through and I'm going to repeat this 5 times, and I'm just going to trace. So the first time through, I take the value of result plus the value of x plus the value of y. I add all of those together. That gives me 7, and that's going to be stored in result. Okay. So you see I made that note off in my table here. And then next I have a condition to check. It says if x mod y is greater than 1. Okay. So x is currently 3. X is currently 3, y is currently 4. So if I take 3 mod 4, what is 3 mod 4? 3 mod 4 is going to be 3. And so the question says, is 3 greater than 1? Okay, because this result, this expression gave me 3. And then is 3 greater than 1? That is true. So because this evaluated to true, that means I'm going to run these 2 statements in here, and I'm not going to run that else statement. Okay. So you'll see in the next line, I take x and I add 2 to it, so it becomes 5. And I take y and I add 1, and that also becomes 5. Okay. And then because I skip my else statement, because my if statement ran, I skip my else, and then I come down and I've reached the end of my loop. Okay. Now the end of the loop means I go back up, do I have to keep repeating? And I do. That was only one time through the loop. I have to do this 4 more times. Okay. So I go through again. I make my tally mark showing that I'm going through a second time. So result is currently 7, X is currently 5, Y is currently 5. If I add all of those together, I get 17, and that becomes my value of result. Then I check this again, X mod Y greater than 1. X is 5, Y is 5. 5 mod 5 is 0. There's no remainder when you divide 5 and 5. And because it's 0, is 0 greater than 1? No, it's not. That is false. It is not. And because that's false, that means that this if statement gets skipped and I run the else statement here. So I'm going to run these 2 lines of code here. So X gets 1 added to it, so it becomes a 6, and Y gets 2 added to it, so it becomes a 7. I've reached the end of my else and the end of my repeat until, the repeat n times, and I go back up and I do it again. So 17, 6, and 7. I add all of those together, I get 30. X mod Y, 6 mod 7 is 6. And so this is a true statement. Is 6 greater than 1? 6 is greater than 1. So I'm going to run these 2 lines of code and skip this. So X gets 2 added to it and becomes 8. And Y gets 1 added to it and becomes 8. I go back up, 4th time through, I get 30 plus 8 plus 8. It gives me 46. I check this result. 8 mod 8 is 0. 0 is not greater than 1. So I skip this and I run these 2 lines of code. X gets 1 added to it and Y gets 2 added to it. I reach the end of my loop, I go back up, and I only have 4 tally marks, and I need to repeat 5 times. So I'm going through one more time, finally. Okay. The 5th time through, 46 plus 9 plus 10 is going to give us 65. Check 9 mod 10. 9 mod 10 is going to be 9, and 9 is greater than 1. This is a true statement, which means that these 2 lines of code are going to run here. So X gets 2 added to it, Y gets 1 added to it. I skip the else. I've reached the end of my loop, and I went through 5 times. So because I went through 5 times and I've reached the end of my loop, I am finished. The values of X, Y, and result, 11, 11, 65. And that's the repeat n times. Pretty straightforward. You repeat a set number of times. Now let's get into the repeat until loop. So the repeat until loop will keep repeating a loop until a certain condition evaluates to true. So this will result in the loop repeating some unknown number of times versus the repeat n times we knew beforehand how many times we were going to have to run. So here the repeat until loop, it might run only once, it might run hundreds of times, it might not even run at all, right? So the repeat until just keeps repeating a segment of code until a condition is true. Some things to note here. If the condition is true to begin with, the loop will never start, right? If the condition is true, the loop will never start. And if the condition will never be true, the loop will never stop. And if the loop never stops, we have something called an infinite loop. Okay? So an infinite loop results in the condition never being true, the loop never stops, an infinite loop. And that will crash our program if we have that anywhere in our code. Okay. So here's what it looks like on the CSP exam. You'll see the repeat until, and then in parentheses, they put a condition. Okay. They put some condition. So repeat until the condition is true, whatever that condition is. And you repeat that block of statements. Okay. Let's look at a regular loop example, a loop that never starts, and an infinite loop. Okay. So what is the value of A after each of these code segments has executed? Well, for a regular loop here, I have A gets the value of 5, and I want to repeat until A is greater than 6. So right now, A is 5. which means it's not greater than 6. So what I'm going to do is I'm going to repeat this single line of code until it happens. So I have A is 5. So then inside here, I add 1 and it becomes 6. Then when I reach the end of my loop, I go back and I check this condition. Is 6 greater than 6? Nope, it is not greater than 6. So I'm going to add 1 more time. I reach the end of my loop, I come back up, and then I check the condition again. Is 7 greater than 6? That is true. So then, because of that, my loop is done. My loop is finished. So I ran this loop twice. I ran until A had a value bigger than 6. Okay. Here's an example of a loop that never starts. So A gets the value of -3, and then it says repeat until A is less than 0. And I say this loop never starts. And that is because A is already less than 0. Okay, so if A is -3, -3 is less than 0. That's true. So because it's true, this loop never ends up running. Okay. The loop never ends up running. An infinite loop. Our last example here. Why is this an infinite loop? So let's say A is going to get the value of 10. Okay. A gets the value of 10, and we repeat this code until A is equal to 14. Okay, so repeat this code segment. So I'm going to go in here. 10 is not equal to 14, so I'm going to add 3. Then I'm going to go back up and I'm going to check. Is 13 equal to 14? No. So I'm going to do this again. I'm going to add 3. Is 16 equal to 14? No. So I'm going to add 3 again. I'm going to add 3 again. And do you see what is happening here? Okay. A is never going to be 14. Okay. And because A will never be equal to 14, this condition will never be true, and I got stuck in an infinite loop. Okay. Your program will keep adding 3 to A until it crashes or until you end it yourself. Okay. That's the repeat until loop. Now I got quite a few examples of tracing these loops. They take a little bit of practice to get used to, but nothing we can't handle. So what's the value of the variables after the code is executed? So let's start off with just some one-liners for these repeat untils. So I have A is 5, and I want to repeat until A is less than or equal to -1. So right now A is 5, it is not less than or equal to -1. So inside it says I'm going to subtract 3. So it becomes 2. I check back up. Is 2 less than or equal to -1? No, it is not. So I subtract 2 again. Is -1 less than or equal to -1? It's true. It is. So that is when I stop. Okay. As soon as you reach the end, you come back up and you check and you can say, yes, that condition is true. You are done. Do not run the code again, because I know we're kind of back up at the top here checking conditions. Do not run the code again after you have decided that it's true. Once it's true, the loop ends and you would move on with any other code underneath that loop. Okay. Let's check B. B starts off as 6, and I repeat until B mod 5 equals 0. Okay. So right now, B is 6. 6 mod 5, that's going to give me 1. So this is a false statement, which means I need to run this line of code, which adds 2 to the value of B. So B becomes 8. Then I check this condition again. Is 8 mod 5 equal to 0? Nope, that's false. 8 mod 5 is 3. So I'm going to come in here and I'm going to repeat this line of code. Add 2. Then B is 10. Is 10 mod 5 equal to 0? That is finally true. Because it's true then, B stands at 10. We do not change it anymore. We do not run the line again. Once that condition is true, we are done. And then the last one, C. C is 10, and I repeat until C is less than or equal to 0. So I subtract 3, subtract 3, subtract 3, it becomes 1. Is 1 less than 0? No. So I do it one more time, and I finally have reached a value that is less than or equal to 0 at -2. Okay. One of the things you might have to do on the AP exam is not only trace like we just did, but they also might ask the question, how many times does the loop iterate? How many times does the code execute inside the loop? There's a few different ways of asking it, but basically, how many times do you loop? So if you have to keep track of that, remember you just do 1, 2, 3, 4. So this loop ran 4 times. Okay. If you count how many times you looped like this, or if you made a tally, you can make a tally off to the side if you know you have to keep track of how many times it loops. But that also might be a question on the AP exam to look out for. Okay, let's get into some longer questions here. I have 4. Again, if at any time you just want to try it on your own, pause the video, but we're going to go through the answers here right now. Okay, so I have 2 variables called look up, and I repeat until look is less than 20 or up is greater than or equal to 50. Okay. So remember what your or statement said. Your or statement said this whole thing is going to be true if this or this is true. So either one of those can be true and my loop is going to stop. They don't both have to be true, although they could be, but they don't have to both be true for an or statement. Okay. So it's always good to read through your code and kind of get a sense for where your stopping point is when you see that repeat until. So the repeat until, I'm going to check both of these conditions, and as soon as one of them is true, I'm going to stop. So I'm going to set up my trace. Look is 50, up is 10. And right now, is 50 less than 20? Nope. Is 10 greater than or equal to 50? Nope. So I'm going to run these 2 lines of code. Okay. Look is 50, and I subtract 10. 50 minus 10 is going to be 40. And then up gets 10 added to it, which becomes 20. Okay. So then I'm going to go check my condition again. Okay. So this condition again, is 40 less than 20? No. Is 20 greater than or equal to 50? No. So I go through and I do these again. Okay. I take look, which is 40, and subtract 20, which is up. So I get 20, and then 30 gets added to up. I check my condition. Is 20 less than 20? No. Okay, careful. There's no equal to there. 20 is not less than 20. That's false. 30 is not greater than or equal to 50. That is also false. So I run the 2 lines of code again, which gives me 20 minus 30, which is negative 10. And then I add 10 to 30. So I get negative 10 and I get 40. I check my condition again, and I have finally found a true statement. Negative 10 is less than 20. So because that's true, I'm going to be done with this loop, okay? Because it was an or statement. The fact that this is false is fine, okay? It's an or statement, so as long as one of them is true, the whole thing is true. So you're done. Negative 10 and 40. Okay, the next one. Now we're going to see an and here, okay? So repeat until boss is greater than or equal to 0 and baby is greater than or equal to 5. So remember your and statements. In order for the whole and statement to be true, and the whole and statement has to be true before we can exit our repeat until, each of these has to be true. So both of these conditions have to be true in order for our loop to stop. Okay. So read through, kind of phrase, this code segment in that way to help your brain know when are you going to stop. And then it makes it a lot easier going through. So boss gets the value of negative 30, and then baby gets the value of negative 20. When we go through, we'll check that condition. Negative 30 greater than 0, that's false. Okay, negative 25 greater than 5, that is also false. So these 2 lines of code are going to run. Okay. So in here, boss times negative 1 means that boss is going to switch to a positive 30. Okay. And then baby gets 10 added to it. So it becomes positive 30 and then negative 10 for the value of baby. And then I go check this again. Is 30 greater than 0? That is true. Is negative 15 greater than or equal to 5? That's false. And it's an and statement. So both of them have to be true. They're not, so I run this code again. Boss becomes negative 30 again. Baby becomes negative 5. I check this right away. This is false. This is also false. So I run the code again. Boss becomes 30, baby becomes 5. I check it. 30 greater than or equal to 0, that is true. Is 5 greater than or equal to 5? That is also true. So the and statement, true and true, results in a true overall statement, and our condition in the loop is true, and the loop ends. Okay. I got 2 more examples here. Okay. Here are the 2 examples. One's in the text code and one's in the block code here. Again, it just wants to know the value of the variables after we have executed the code. So here I get x is 2, result is 1, and I want to repeat until x is greater than or equal to 5. Okay. Repeat until x is greater than or equal to 5. So it's not at the moment. X is 2, which is not greater than 5. I'm going to run these 2. Result 2 times 1 is 2, and then I add 1 to x and becomes 3. 3 is not greater than 5, so I take 3 times 2, which is 6, and I add 1 to x. 4 is not greater than 5, so 4 times 6 is 24, add 1 to 5. 5 is not greater than 5, don't let that fool you, so I have to run the code again. 5 times 24 is 120, add 1 to x. And then now x is finally greater than 5. I have 6 greater than 5. It is true, so the loop ends there. So the values of my variables are going to be 6 and 120. All right. And then now my last piece of code here in a block format, just so you can kind of see it. A starts off as 8, B starts off as 0, okay, and repeat until A is less than B. Okay, so very important, as you go through here, make sure that you're not confusing these statements with relationships. The statements run once at their current values, and then when you go back and loop and do it again, they run at their current values of A and B, which is why tracing is very important here. So this first line, repeat until, well, 8's less than 0, so I repeat this. So I go to this line right here. Okay, it works for the current value of A and B. So B is 0 plus 8 divided by 2. Okay, remember order of operations, you're going to do this first. So 4. 4 plus 0 is 4, and that gets stored in the value of B. Okay, so that's why B is 4. A gets 2 added to it, and that's going to become 10. Go back up and check the condition. Is A less than B? It is not. So you're going to go through again and make sure now when you go through again and you revisit this line of code, we're using the current values of A and B. So B is 4, A is 10. Okay. Order of operations here, 10 divided by 2 is 5. 4 plus 5 is 7. Oops. I guess I messed that up myself. 4 plus 5 is 7. Ooh, how did I get, or no, 4 plus 5 is 9. Oh my goodness. Look at me. Just trust it. So I cross off 4. Can't see it there. Okay, so again, that was 4 plus 10 divided by 2. Ooh. Oh, do you know what I was thinking real quick? Because if you didn't do order of operations and you just did left to right, look what you would get. You would get 7, right? But the answer is not 7, it's 9, and that's because of order of operations. Okay, please do not make that mistake. You do the division first. 4 plus 5 is 9. Okay, and then we take A plus 2 to give us 12. Is 12 less than 9? No. Let's do it again. How do we get 15? Let's make sure I didn't mess up this time. 9 plus 12 divided by 2. Okay, 12 divided by 2 is 6. 9 plus 6 is going to be 15. Okay. If you don't do order of operations, you start getting into decimals, which would be okay on the exam. You can get decimals on the CSP code, but it just, it would be incorrect. And then I add 2 to A, and then I check. Is A less than B? It is finally true. 14 is less than 15. And because it's true, the loop ends at that moment with A being 14 and B being 15. So even though you go back up at the end to check your condition again, do not go through the code. As soon as the condition is true, the loop is going to end with that repeat until. Now let's go over writing iteration statements. So you won't have to write any iteration statements on the AP exam, but you might be asked to kind of translate between the two loops we just learned about. Now when it comes to writing and creating a loop in your program, when you're using one of your programming languages, loops, where do I put them? You ask two questions. What do I want to repeat? And when do I want the loop to stop repeating? So if there's something in your code that you want to be repeated, it'll just kind of naturally come up in your program. That's when you're going to write a loop. And then how do you decide which loop? Well, if you want the loop to stop after a set number of times, use a repeat n times loop. So this would be if you need the loop to stop, after 5 times. Like I want to run this code segment 5 times. That's it. I already know. Then a repeat n times loop will be good. If you want the loop to stop after a certain condition is met, but you don't know how many loops that will take, we use a repeat until loop. So if there's something that is unpredictable in your program that maybe depends on user input or something like that, we would use a repeat until loop to get that done. And in some cases, you can actually interchange these, and it's up to you as the programmer what you would like to do. So just for practice, in the following table, we're going to write the equivalent repeat n times loop or a repeat until loop, so the code segments produce the same result. So in this table, I have, starting off over here, a repeat until loop. I is 0, repeat until I is greater than or equal to 5, display I, and then I increases by 1. So I want to write this code, but I want to write it repeat n times, okay? So in order to do that and have the code segment produce the same result, that's the key here in the directions, I want to know what does this repeat until loop do? So let me trace through this. I is going to start off as 0. Repeat until I is greater than or equal to 5. It is not. So what am I going to display? Well, I'm going to have a little display column to trace out. Okay, so I display 0 because I is currently 0, and then I increases by 1. Okay. 1 is not greater than or equal to 5, so I'm going to display 1. I increases to 2. 2 is not greater than or equal to 5, so I display 2, and then I increases to 3. 3 is not bigger than or equal to 5, so you see, oops, I didn't mean to cross that off, sorry. The display will not get crossed off. I display 3, increase to 4. I display 4, increase to 5. And then I check, is 5 greater than or equal to 5? Yes, it is. So my loop ends. And this code segment is going to display 0, 1, 2, 3, 4. Now, in the pseudocode, it displays that all on a line. So I kind of made it vertically just to make enough room. But in the pseudocode, it displays it all on a line with a space between it, between each number. And that's part of the exam reference sheet if you need reminders about what the display actually will do in your pseudocode. It says it displays what's in parentheses and then, or the value of what's in parentheses. So here it would display the value of I, and then followed by a space, and it keeps going on the same line. Okay, so that's the repeat until. That's what's actually happening in this repeat until. Now I want to write it as a repeat n times. Okay? So repeat n times, I need a set number of times. So how many times am I going to repeat? Well, and what am I going to repeat? Well, first, what am I going to repeat? I just want to repeat this. This is all I need to repeat. If I start off with I is equal to 0, I display 0, increase by 1. Display 1, increase to 2, so on and so forth. How many times am I doing that? Well, I did it 1, 2, 3, 4 times. So what I'll find is my loop almost looks identical except for that repeat n times. Okay. Again, I start off as I is 0. I have the same statements inside because I'm still repeating that code segment. And now how many times? Okay. Well, we just said loop goes 5 times, It displays 0, 1, 2, 3, and then 4. So that's 5 times. Sorry, I think I misspoke and I said 4 earlier. But the loop goes 5 times here. It loops through 5 times. So repeat n times. I'm going to repeat 5 times. Okay. There. Oh, I know what I did. Okay, that's why I said, because I was looking at the display. Okay. And when I look at the display, why did I say 4 times? Because I did 1, 2, 3, 4, but that's incorrect, right? And that's not what's happening here, because the display is just how many times does this line of code run. And we can count here, it gets ran 5 times. If I wanted to do my skip method like I did, I have to do with the I. 1, 2, 3, 4, 5. Okay. How many times does I change? And that's because I started off on the outside as a value, and then it changed. It went through 5 different changes until the loop finally ended when it became 5. Okay. So please be careful of that. Don't make that mistake. All right, next I have a repeat n times right here. And I want to write as a repeat until. So again, I want to just trace through this and understand what is happening. So sum is going to be 0, x is going to be 3, and I repeat 3 times. I add sum and x together, and that becomes my new sum. And then I subtract 2 from x. And that was 1 time. The second time, I add them together, subtract 2 gives me -1. And then the third time through, I add them together, I get 3, and then I subtract 2 and I get -3. And that's repeating that loop 3 times. So I end when sum is 3 and x is -3. So if I want to write that as a repeat until, what stays the same and what do I have to change? Well, what stays the same? My starting values need to stay the same, and what I'm actually repeating inside the loop is going to stay the same. The only thing that's going to change is this loop header. And how is it going to change? Well, it's going to be a repeat until. So notice everything's the same. It's just the loop header that's going to change. And remember, I ended this loop, the outcome, sum was 3 and x was -3. Okay. So what condition do I make as my stopping point for this repeat until? Well, here's where you have some options. Okay, there's actually many answers you can put down. You can say repeat until like x equals -3. Repeat until sum equals 3. You could be fancy, say repeat until x equals -3 and sum equals 3, right? When both of those are true. You can have many options here. You can even do a, something like repeat until x is less than or equal to -3. Right? Or repeat until x less than -2. Or do an interval with sum of some kind. There's many different options you can put down as your stopping point. I think I put down x equals -3 here. Yeah, because I just traced the value of x here. But you can definitely include sum as well. So on the AP exam, even though you won't be writing pseudocode, it is fair game for them to ask you to kind of go back and forth between the 2 loops like we just did here. And the last thing I want to talk about is nested loops. Now, we won't run into a lot of these in this course, but they do have their uses really their uses, the first time you'll see them in an advanced programming course would involve 2-dimensional matrices. We see them a lot, and a few more advanced data structures. We're going to keep it real simple and just work on tracing nested loops. So you might not actually have a situation at the moment where you need to write a nested loop and use it for a purpose. But the important piece right now, I just want you to be able to trace them. And a nested loop is kind of like it says, it's where you put one loop inside of another loop, and it just takes some practice learning how to trace these. Nested loops do help create more complex repeating code. Again, that's why we kind of see them with more complex data structures that we don't really encounter in this course. But I do want you to be able to trace them. They are important. The key with nested loops is that the inner loop has to run through all of its sequences before the outer loop runs again. Okay, so you'll see we start the outer loop, and then the inner loop has to go through all of its repeat until or repeat n times until the outer loop actually gets repeated. So let's look at an example of a nested loop and then trace through this. So we're gonna first look and recognize that this is a nested loop. I'm going to repeat 3 times, that's my outer loop, and this repeat 4 times is going to be my inner loop, okay? So recognize that it's a nested loop, and then how do we trace this? Well, my outer loop runs 1 time first. I go here to my inner loop, and the inner loop runs all of its sequences. So this is going to display 4 times before I come to the end of my outside loop. Okay, so what that looks like is I go through first, that's my tally. I repeat 4 times, 1, 2, 3, and 4. So I display my star, my asterisk. Once that 4 gets displayed, okay, I've reached the end of not only the end of my inner loop, but the end of my outer loop. So I come back around, I go a second time through, so you see that second tally mark, and I come in and I do it 4 more times. So I made it a different color on the screen just so you can kind of see the difference, but they all get printed in a row here. So repeat 4 times, I displayed that, that's the blue asterisk. I reach the end of my repeat 4 times, end of my repeat 3 times, and then I need to go 1 more time because I'm repeating this 3 times. So I do that, I reach inside 4 more times, so that's the green asterisk there. 4 stars get displayed. I reach the end of that, and I've repeated my outer loop 3 times. Okay, so this inner loop, okay, actually got repeated 4 times on 3 separate occasions. Okay, so when we talk about how many total asterisks are printed, if you count these up, it's going to be 12. Okay, well, mathematically, where else do you see getting a 12? Well, for nested loops, if it's running a set amount of time, this doesn't count as a repeat until, but if we know a set amount of times that each the outer loop and the inner loop repeat, how many total times will this inside statement run? You just multiply those 2 numbers. Okay? And that's just more of a fun fact. You don't actually have to memorize that or anything because you can always just trace through and see what happens. But this would be kind of a typical exam question on nested loops, right? How many total asterisks are printed? And then they would give you 4 choices and you would choose 12. Okay, something like that. Or asking, what is displayed after the nested loop. You're just tracing through these nested loops. Don't worry too much about when you'll use them. I really just want you to be able to trace them at this point. And that wraps up our lesson on loops. Thank you guys so much for following along. If you have liked this video, please hit the like button and subscribe to my YouTube channel for more great computer science content. Until then, keep coding, keep learning, and I will see you in the next video.